So in this video, we're going to be talking about percent yield. And percent yield is basically, we want to calculate how much of a substance we actually produced versus how much should have been produced ideally. So the formula for percent yield is quite simple. We take the actual yield, which is what we're actually going to get, and we divide it by the theoretical yield, which we're going to calculate from a stoichiometry problem or reaction, times 100 is going to be equal to percent yield, which of course is going to be unitless. So in this case, a very, very simple example is, imagine that a reaction has a theoretical yield of 10 grams, but you actually only produced, actual yield, you only produced 8 grams of a specific product. So this would be very straightforward. We take 8, which is my actual yield, divided by 10, and then multiply it times 100. And after we do this operation, we know that the percent yield is 80%. Of course, when we're speaking about chemical reactions, it's not going to be that simple because we need to balance a reaction. We need to get these factors in order. So let's dive right into one of these problems, and what we're going to calculate, of course, is percent yield. And first I want to make sure that I balance out my chemical equation. So I see that it's not balanced, so I need to add a 4 here for the phosphorus. And now that changes my chlorine count over here to 12. And that means I'm going to add a 6 over here. So my reaction is balanced, and now I can work with it. So if we remember, percent yield is equal to the actual yield divided by the theoretical yield times 100. And if I read the problem, if only 60 grams of phosphorus trichloride were produced from 60 grams of chlorine, what is the percent yield? So we already have the actual yield because it says if only 60 grams of phosphorus trichloride were produced. So we're just going to plug it in right here. And my actual yield is 60 grams of phosphorus trichloride, meaning that we want to calculate the theoretical yield of phosphorus trichloride and multiply it times 100. So for that, I'm going to set up a mass problem with the 60 grams of chlorine. So 60 grams of chlorine over 1. Then I add the molar mass of chlorine, which is 70.9 grams of chlorine for every mole of chlorine. Next up is 6 moles of chlorine. Why 6? Because that comes from the balance equation. And I want to convert to moles of phosphorus trichloride. So phosphorus trichloride goes here. And my last step is to calculate the molar mass of phosphorus trichloride, which is, if I add up 3 atoms of chlorine and 1 of phosphorus, gives me 137.32 grams of phosphorus trichloride. So right now with this number, what we did is we calculated the actual yield of chlorine. 60 times 4 times 137.32 divided by 70.9 times 6. And that gives me a grand total of, rounded up, 77.47 grams of phosphorus trichloride. So in this case, this is my theoretical yield. And now I can just take this number and put it into the formula and write 77.47. And then it's just very simple math. I'm going to take 60 and divide it by 77.47 and then multiply it times 100 and round it up. And my percentage is very interesting because it gives me, if I did this right, oh, so interesting, 77.45% yield of phosphorus trichloride. So in this case, I'm going to box it because this is my final answer. And it's very simple. So remember, we were given 2 pieces of information, an actual yield, and we were given one of the reactants so that we can calculate our theoretical yield, and then we multiplied by 100. Now, another example which we can get is, we have this reaction, of course, and it says if the percent yield of water was 55.27 and 319.80 grams of oxygen were used, how much water was actually produced in grams? So here, let's take the vocabulary, and once again, we can chop up this problem in many different ways, The first thing I'm going to do though is balance, just to make sure. Is this balanced? It's not. I added 2 to balance the oxygen, but now hydrogen became 4 on this side. We have 2. I'm going to add a 2, and now we're balanced. So remember, actual yield divided by theoretical yield times 100 equals percent yield. Okay? So what I'm going to try to do here is I'm going to do the algebraic manipulation so that we're going to get our answer right away at the end. So what we're looking for is, if the percent yield of water was 55.27, which we already have, let's just plug it right there, and it's 55.27, and 319.80 grams of water of oxygen were used. How much water was actually produced in grams? So we don't have all the pieces of information here. We only have the way to calculate theoretical yield. So in order to get that theoretical yield over here, what do I need to do? I need to take this given, which is one of the reactants involved, and we're going to take a mass problem, and we're going to say 319.80 grams of oxygen over 1. The molar mass of diatomic oxygen is 31.98 grams of oxygen over 1 mole of oxygen. Then we look at our chemical equation to convert to moles. Moles of oxygen, and we want to know moles of water, which is 1 mole of oxygen for every 2 moles of water from our balanced equation. And last but not least, the molar mass of water, which is 18.01 grams of water. So once we punch this into the calculator, and after everything cancels out, we take 319.80 times 2 times 18.01, and we divide it by 31.98. So this reaction should have given us, theoretically, 360.20 grams of water. So this is equal to our theoretical yield. So now we have enough information, because the percent yield was given by the problem. We calculated the theoretical yield, and now all we have to do is a little bit of algebra. So AY times 100 divided by 360.20 is equal to 55.27. So I'm going to switch this 360 on the other side by multiplying. And I'm going to do that in another color so that it's a little bit more clear. So I multiply on both sides by 360.20 to cancel it out. So we have 55.27 times 360.20 gives us a big number. So we have the actual yield times 100 is equal to 19,908.25. And at the end of the day, we're going to take, again, the other marker, and we're going to divide by 100 this time. And this is going to give us the actual yield. So we take 19908.25, and we divide this by 100, and we have rounded up that the actual yield is 199.08 what? Grams of water, which is what was being asked. Grams of water. So we actually produced 199.08 when we should have produced theoretically 360, and we got this from the reverse exercise where we were given the percent yield and we were given the way to calculate theoretical yield, and then we did some algebra, and my actual yield of water is 199.08 grams.